Hello, Year 11s. Welcome to our final lesson of your holiday homework and final exercise in Chapter 16. Okay, so we're dealing with position and average velocity from 16E. Okay, so the average velocity of a particle is the average rate of change in position with respect to time. Okay, so if we're talking about the average velocity, okay, we're talking about the average rate of change in position. Okay, so any students that are studying physics, you're going to get quite a bit of practice with velocity and position. Okay, this just further emphasizes those concepts. Okay, so average velocity is equal to the change in position divided by time. Okay, the time elapsed. Okay, that's what it says with respect to time. Okay, so that's the formula. You will need it, so chuck that into your band references. Okay, an example. So what we've got is let S of t equal 6t minus t squared, okay, be the position function of a particle moving in a straight line, where t is in seconds and s is in meters, okay. So this is this formula, okay. So 6t minus t squared, this is what it looks like when it's graphed, okay. Remember, the negative t represents a negative parabola, and you'll get your intercepts at 0 and 6, okay. So part A says find the average velocity, okay, for the time interval 0, 1. Okay, so the average velocity between 0 and 1, as I'm drawing down there. Okay, so we're trying to find the average velocity between these points. Okay, so we put 0 into the equation. That's our starting point, so that's going to be 0. Okay, so 6 times 0 minus 0 squared is still 0. And then we put 1 into the formula. So 6 times 1 minus 1 squared, which equals 5. So that location will be right there at 5, so that's at 1, 5, and then this one down and below is 0, 0. Okay, so we're trying to find the average rate of change. You can probably see it in your head if you're able to work it out. So the change of position is 5 meters, therefore the average velocity will be 5 divided by 1. So it's a change of position divided by the change in time. We get 5 meters per second. Okay, and that's what that terminology represents. So it's traveling 5 meters for every second within the first time interval of 0 to 1. Okay, and that's what those points represent. So the 0 is the 1 down there, and then the 5 is the 1 across. Okay, so moving on to the second part, we've got our graph. So we've got let S of t equals that, be the position function of the moving particle in a straight line where t is in seconds. Okay, so find the average velocity for the time interval 6 to 8. So what I've done is, with the graph over here, you can use your calculator for these things, okay? So please make sure you're getting familiar with your calculator and graphing, okay? So we've got a particular time here, which is about 6, and then somewhere here where there is 8, okay? And we're going to try and find its average velocity, okay? So when we put 6 into the formula, so 6 times 6 minus 6 squared is 0, okay? So this first coordinate here, it will be 6, 0. Our next one is when we put an 8 into the formula, so S of 8. So 6 times 8, 48, minus 8 squared, 64. So 48 minus 64 is negative 16. So somewhere down here, around about there, okay, we get a coordinate of minus, sorry, not minus, we got 8, minus 16. Okay, that's the point. So we're trying to find, between these two axes, the average velocity, okay, which is the change in position divided by change in time. Okay, so the average velocity is 16, take away 0. So remember, we need to keep our negatives. We have a negative rate of change because our rate of change is our slope. Okay, so we get a negative slope, so I'm expecting a negative answer. Okay, so I get negative 16 minus 0, which is negative 16, divided by 8 minus 6, which is 2. So negative 16 divided by 2 is negative 8 meters per second. So what that means, for every 1 second we're traveling, during this time, this person is traveling back negative 8. So traveling negative 8 meters. Okay, and that's what those 2 points represent. Okay, so I've drawn the arrows across to sort of point those into play of what they are. What you need to do is you need to do all the questions for 16E. Okay, I don't think there's too many, but you just need to do them all, and then move on to the chapter review. Okay, so plus 16 review. Okay. Once this is completed, that is all of your holiday homework completed to be done. And then when we come back, we will be moving on to chapter 17. And you will have a SAC for Chapter 14 to catch up as well. I believe that'll be the start of the second week, but I will communicate that to everybody as soon as possible. Okay, so good luck. Hopefully it's not too much work over the holidays, and I will see you in term 3. Thanks, guys.